Continuing our discussion on speed. Speed comes in two flavors. Average speed is the total distance traveled divided by the total travel time. So what that means, when you were on your way to school this morning, you probably didn't travel the same speed the entire time. You maybe had to stop at a stop sign, went to a gas station to grab some food before you got here. You had to drop your little sister off at middle school. But your average speed over that trip was the entire distance from home to school divided by the total time it took to get there. Instantaneous speed is the speed at a given point in time. So you're driving down the road at 65 miles per hour and you come up on a town, there's going to be a speed limit change. You need to look down at your speedometer and make sure that you slow down so at that exact time when you cross there, you don't get a speeding ticket. Speed describes only how fast something is moving. There's no direction associated with it. It's what we call a scalar quantity. Velocity, on the other hand, includes the speed of an object and the direction of its motion. So our examples are 40 miles per hour north or 5 meters per second up. So sometimes it is definitely important to know which direction you are moving in. Like if you're out fishing on the lake and you want to go back to the dock, you need to know which direction you're moving in so you can get back home. Or if you're out in the woods, you might be walking at 3 miles per hour, but you should probably have a compass with you so you know which direction you're going so you don't get lost. Velocity can change in two ways. You can have a change in speed, meaning you can speed up or you can slow down. Or, since it's a vector quantity, you can have a change in direction, or both can happen. An example is a race car moving at a constant speed of 100 kilometers per hour around an oval track. Even though it's going the same speed the entire time, it's constantly changing direction, so its velocity is changing. We're going to work on an activity with graphing motion. So on a distance versus time graph, on your x-axis down here is time, and running up the y-axis is your distance. And so how you read a distance versus time graph, you look at any given point, say right here, and you look over and you say, okay, I went 150 kilometers in just over 2 hours. So that is your speed. And if you look at the slope of the line, that tells you, that represents the speed the object is moving at. So we have what is called positive speed. Positive speed means you're moving away from the origin or reference point. The graph will have a positive upward slope. With a constant positive speed, like we have here, right down here will be your origin at position 0 times 0, and you will have a straight line moving at an upward slope like that. Speed isn't changing because it's a flat, straight line. And as we said, the slope of the line tells you the speed the object is moving at. So if you have a steeper slope, you're moving faster. If you have a shallower slope, you're moving slower. In real life, we don't always travel at exactly the same speed. Like you said before, sometimes you got to speed up, sometimes you got to slow down. So if you look here, at the start of our distance versus time graph, we have a pretty shallow line, so we're moving slowly, and then up here it's steeper, so we know that we are speeding up. An exact opposite. Right here, steep line means a faster speed, and here we slow down. So this is like you're merging onto the interstate. You're moving slowly down the ramp and you speed up and then you're going 80 miles per hour. And this is the exact opposite. You're moving 80 miles per hour, you see your exit, you slow down, you come to a stop at the stop sign. So negative speed means we're moving back towards the origin or reference point. So our graph is going to have a negative downward slope. And we see over here, constant negative speed. It's a straight line, but it's moving back towards the origin on the distance axis. And again, we can have a fast negative speed or a slow negative speed, and you can tell that by the slope of the line. And just like with positive speed, we can change our negative speed, how fast we are moving in a negative position direction. So here, we're going from slow to fast, and from here, fast to slow back towards the origin of the position axis. And one more thing I want to touch on. If we look at this graph, we can see that time is increasing. You can see the blue line, but distance isn't changing at all. So if we have a horizontal line with zero slope, it indicates that no motion is taking place.